Hello there. Welcome to IT Physics channel. Today let's do a revision on the concept of forces. Everyone has a basic understanding of the concept of force from everyday experiences. So what is a force and how do you define a force? A force is a push or pull. You can simply imagine a force as a push or pull. And what is the unit of the force? The unit is used to write down using big N. So this is our unit of a force. And also, force is a vector quantity, meaning it has direction as well as magnitude. You can represent a force using a small arrow. The length of this arrow implies the magnitude of the force, and this small cap indicates its direction. Mathematically speaking, you can imagine or you can represent a force using a simple arrow. Now let's imagine two situations where two objects are pushed on the same surface by a same person. So let's assume pushing an iPhone as well as a hammer. He will realize he needs more force to push a hammer than push his iPhone. I mean, that is true. If he uses a same surface, he will realize he needs actually more force to push a hammer than push his iPhone. Basically, forces help us to move an object from one point to another. And this is actually based on the surface roughness and the mass of the object. So based on the surface roughness and the mass of the object, you will feel you need to actually apply different forces to move an object from one place to another. But remember, the forces do not always cause motion. Sometimes there would be a force but the object won't move. Imagine a situation, a person sitting on a chair. If a person sitting on a chair, there is a gravitational force is acting on his body, but he remains at the same place. What is the reason behind this? Why he is not actually moving towards the earth? Because there is a force acting on his body. And similarly, imagine push a boulder or push a wall. If you try to push a wall, it won't move. You are applying a force, but yet it won't move. So these are the situations you actually apply a force, but it does not cause any motion. Okay, so what force causes the moon to orbit the earth? Imagine now the situation. Let's consider Earth-Moon system. If you consider Earth-Moon system, Moon is orbiting the Earth in a circular orbit. It's not precisely circular. Let's assume it's a circular orbit. This arrow indicates the velocity vector of the Moon. The length indicates its magnitude and this cap indicates its direction. You can see now the velocity vector, the direction of the vector is changing even though the magnitude doesn't change. So what is the reason behind this? This change in velocity is actually caused by the gravitational force exerted by the Earth on the Moon. That is the reason this Moon system starts to move along this circular path. There is a force acting on the Moon, but this force is actually acting through this empty space. You can imagine there is no physical contact. These two objects are not actually physically connected, but yet there is a force acting on this system. Now let's move to the classification of forces. We classify forces into two main categories. One is contact forces, other one is field forces. So what is contact forces? Imagine a situation, a spring is pulled, okay? So this side of the spring is attached to a ceiling and you give a small push or pull. And in this situation, the spring and the person who is giving a force, these two are physically connected. And imagine this situation, a stationary cart is pulled. So even in this case, this system and the person who is pushing or pulling this object are connected. Physically, these two objects are connected. We say something is contact force if there are physical contact between these two objects. Hence the name is contact forces. And this is our second class, field forces. Field force does not involve in any physical contact between the bodies, and field forces actually act through empty space. Imagine a situation, Earth-Moon system. If you take our Earth and Moon follows a circular trajectory around the Earth. At each point, the velocity of the Moon will change. And we said this change in velocity is actually caused by the gravitational force exerted by the Earth on the Moon. So this gravitational force is a force is caused between these two objects, and you can see in between you have empty space. So gravitational force is actually a field force. And in this example, a small negative charge is kept close to a positive charge. So this small charge would be attracted towards this positive charge. And in between you have empty space, and these two are physically not connected. Hence this force, this electric force, also a field force. And the third one, look at this one. A small iron piece is actually kept close to a magnet. If you keep, this will start to move. And you can see there is an empty space in between, and still there is a force acting on this iron piece. Therefore this force also under this category, the field force. So in microscopic point of view, all the classified contact forces turn out to be caused by electric forces. In macroscopic point of view, actually we talk about the contact forces, but if you come to a atomic scale or the microscopic point of view, whatever the classified forces, the contact forces, you can say, okay, everything is caused by electric forces. And finally, these are the fundamental forces in nature. The first one discovered, or at least the mathematical framework was actually developed by Sir Isaac Newton, the gravitational forces. And the second one is electromagnetic forces. This is also one of the fundamental forces. And the third one, strong nuclear forces. You can observe these kinds of strong nuclear forces within nucleus. And the final one is weak nuclear forces. You can observe this in radioactive decay process. So these are the main ideas, so the main concept you should know under the forces. So thank you for watching my YouTube channel. If you like my videos, please subscribe to my channel. See you next time. Bye.